Hello students. Today we will myself Sanjay Singh, uh, Government Engineering College Ajmer. Today we will learn the 8279 keyboard display controller. As we know, 8085 microprocessor have several peripheral devices that is to be connected, and these devices are controlled through the various types of controllers. For example, we have already studied about 8255, that is PPI, programmable peripheral interface, that is general interface to connect the various input output devices. Today we will learn the 8279. 8279 is a keyboard display controller. 8279 is a Intel product, and as we know, as at 8085, 8279 also have 40 pins. These pins are showed in the pin diagram, that is pin number 1 to pin number 40. Pin number 1, 2, uh, and 38, 39, these are used for keyboard controller, and majorly these 40 pins are grouped into four categories or four groups. These four groups are like this. Uh, for example, these 8 pins, that is A0 to A3 and B0 to B3, these are used for display device. Uh, and this one, uh, this 879 also used for scan section, keyboard section, and display section. There are four major categories of signals, and these signals are connected to the microprocessor through various pins. Oh, this section is used to connect the microprocessor, and these sections will be connected to keyboard. For example, this side the keyboard will be connected, this side the scanner will be connected, this side the output device will be connected. Now there are this is the description uh, about the 8279. Now I will show the description about 8279. That is that is this is the block diagram of 8279, and in this block diagram you will see that there are four major sections. One section, this one, this will be connected to the 8085 microprocessor, or 8086, or 8088. Here data buffer, that is used to buffering of the data, that is to come from microprocessor and to the microprocessor. And these are the read, write, and chip selection signals. These are used by the control unit of microprocessor. This is interrupt request register. For example, any device that wants to communicate with the microprocessor will go through this interrupt request signal, and this portion, this whole portion is used for connection of microprocessor, and the lower portion, this one, these are used for keyboard, display, and scan section. So in uh, keyboard section, there are 8 lines, RL0 to RL7, and uh, the function of RL0 to RL7 will be changed with shift and control stop signals. This is the scan section. This is used by the scanner, and this is the output, yeah, display section. This section is used for display devices. Any data that is comes from the display device or that is to be displayed on display device will be come from display RAM. Means display RAM is a buffer portion. Display RAM is a buffer portion to buffering of the data. Display address register provides the address of the display device that is to be connected with the microprocessor. And control and timing register contains the status and control information that is uh, carried out from microprocessor. Microprocessor will send this information in form of control word, and this control word are uh, come through address bus and stored in the control and timing register. This is FIFO sensor RAM. This RAM is basically used for uh, buffering of information of keyboard and display device. Keyboard debounce and control are this control is used for keyboard section. So now we will see there are four major sections of 8279 keyboard display controller. That is keyboard section, scan section, display section, and CPU interface. The keyboard section consists of eight lines RL0 to RL7 that can be used to form a column of keyboard matrix. It has additional inputs, shift and control. These keys are automatically debounced. The two operating modes of keyboard section are 2-key lockout and N-key rollover. In 2-key lockout mode, if two keys are pressed simultaneously, only the first key is recognized. And in N-key rollover mode, simultaneously keys are recognized and their codes are stored in the FIFO RAM. The keyboard section also have 8 by 8 FIFO RAM that is used for storing of the keyboard data. The FIFO can store 8 key codes in the scan keyboard mode. The status of the keys and control keys are also stored along with the key. The 8279 generates an interrupt signal when there is an entry. The format of key entry in the FIFO for scan keyboard mode is this is the entry for D0 to D7. These binary these start LSB binary 3 bits binary values which are used for key closure detection, and these are used for columns and these are used for rows. These two keys are used for shift key and the control key. In the sensor matrix mode condition, 64 switches are stored in FIFO RAM. If the condition of any of the switch changed from 8279 assert IRQ high interrupt to the processor. And the display section, have 8 output lines divided into two groups, A0 to A3 and B0 to B3. The output lines can be used either a single group of 8 lines or a group of 4 lines in conjugation with the scan lines multiplexed with the display. The output lines are connected to the nodes through the driver transistor in case of common cathode 7 segment LEDs. The cathodes are connected to the scan through drivers and transistors. The display can be blanked by BW low line. The display section consists of 8 by 16 by 8 display RAM. CPU can read from or write into any location of the display RAM. Scan section has scan counter of 4 lines SL0 to SL3. In a decoded scan mode, output scan lines will be similar to 2 to 4 decoder. In encoded scan mode, the output of scan lines binary out. So the external decoder should be used to convert binary count to decoded output. Scan lines are common for keyboard and display. The scan lines are used of a matrix keyboard and also connected to digit driver of a multiplex display turned to off and on. Now, the fourth section is CPU interface section. The CPU interface section take care of data transfer between 8279 and the processor. This section has 8 bidirectional data lines, that is DB0 to DB7, like other peripheral controllers we have seen, like 8255, 8251 already we have seen. It requires two internal addresses A0 for selecting the data bus and A equals to 1 for selecting the control register of 8279. The control signals, that is write, read, chip selection and A0, are used for read write of 8279. It has an interrupt request line for interrupt-driven data transfer with processor. 8279 requires an internal clock frequency of 100 kHz. This can be obtained by dividing the input clock by a internal prescaler. The reset signal sets the 8279 in 16-character display with two key lockout or keyboard modes. So 8279 can be programmed to function various command words, and the programming of 8279 for interfacing with uh, the 8085 microprocessor will be shown in another lecture. So the main functions of 8279 or the important features of 8279, that is block diagram. One section is used for connection with the microprocessor. This section will be connect with the microprocessor, and these three sections used for connection with the keyboard, scanner, and the display device. So that's all about the today's lecture of